One that's completely awesome. If we have each of x,
Man, it looks like Comic Sam.
So as more and more brackets are added, do you just put more primes?
I don't even know what that means. Okay, I'm going to hit pause.
Comic Sans is a font.
Yes, I know, but I don't know why everyone's laughing. Okay, 2 times 2x, whoops. It is 2 times 2x minus 3, almost. And then still times 2. Why, okay guys, can I please, guys, can I stop? Why do I have to do the times 2 at the end here? Because of the chain rule, right? It's the derivative of the middle. John?
Now, I like to simplify things. Is it possible at that step to just multiply it all together?
If you want to.
Will that affect my answer?
Yes, it will. I'm going to do that because the 2x minus 3s we're going to want to factor out long term.
Okay.
Okay, so I wouldn't do that. Okay, in blue, I'm going to do g of x equals 4x minus 1 cubed. G prime of x is going to equal, yeah, go ahead.
3 times 4 of x minus 1 squared. Times 1.
Okay, now, you guys can choose not to do this. Okay, if you don't want to write those out at the top, that's fine. Okay, but it's somewhat helpful. So, the way, I know you guys are all talking about math, I understand that, but it's very, no, it really is it's difficult for me to teach when people are doing this. I know you're doing math stuff, I know, but it's hard for me, I'm sorry, okay? Can someone be brave and try and give me h prime of x the first step? Courtney, you're brave, you can do it. Yeah? Yeah. Yeah. Awesome. Now, you might say, Mr. Sadler, I did mine backwards. That's fine. Okay, right? As long as it sort of looks something like that. If you have extra brackets in there, that's okay as long as it matches up. Does that make sense? Hold on a sec. Does that make sense what happened with there? So what happened, what she did was, she left, this is f of x, this is f prime of x, this is g of x, sorry, whoops. This is g of x, that's f prime of x. Did I say that backwards? F of x, g prime of x, g of x, f prime of x. Okay? Graham, what is common between both of those, please?
4 times 4 bracket 2x minus 3 bracket 4x minus 1 squared.
Awesome. Now this is where I just want to make sure we're good. If you scan all the way along both those terms, if you scan along both those terms, both of them can be divided by 4, both of them can be divided by 2x minus 3, and both of them have two 4x plus 1s. Robert Murray, what is left inside the brackets, please?
Inside the bracket?
Yeah.
2x minus 3.
Yeah.
Times 3.
Yeah.
Plus 4x minus 1.
Plus 4x minus 1. Okay, so John was saying before, he said, could I change this to 12x to whatever? The problem is if you do that, John, it's going to be a hard time getting things to simplify this step, right? You'll still get the right answer, but you have to do a little bit more work at the end. Austin, I'm not done. What do I still have to do?
Bring the brackets together.
Yeah, so go ahead.
So you're going to have 6x minus 9 plus 4x minus 1, and then simplify that.
And that turns to 6x minus 9 plus 4x minus 1. That turns into 4 bracket 2x minus 3 x minus 1 squared 10x minus 10. Okay, Dakota. I look at that and there's one thing glaring at me that I should still do. What is it, Dakota?
You can factor out a 10 from the 10x.
You certainly can and you should, okay? So this should turn into h prime of x equals 40, 2x minus 3, 4x minus 1 squared. And if that doesn't give you chills, nothing in this world will. Okay. Now, then you might say, why is University Calculus hard? Because what they'll do in University Calculus, they'll give you this, and they'll say, make it look like this. Right? That's why it's difficult. Okay, right?
What's
Yes.
the point of being able to find h prime of x is two functions times times?
Well, because I could say, what will happen is in the next year, we're going to graph this.
I just want like a real life example.
For a lot of this calculus stuff, a lot of this theoretical, like you say.
Oh, okay.
Okay, right? Like, for this, it's, I can't say I'll be walking down the street and to do these derivatives of this. Okay, there's not too much of that, okay? But for this here, this will really easily help you to graph. Like, to graph this using advanced functions methods is difficult. Well, not really, I guess there's roots and stuff, but we can get a very, very accurate picture. Okay, sorry, guys, go ahead.
Are they,
Just wait, I can't hear. Sorry, guys, I can't hear.
are they gonna get a lot harder than this? Or is
I'm going to
this-
try example 5, which will be a little bit harder, and then I'm going to do that awful question off the test in 2 steps, in about 10 seconds. Okay? Remember the first question with the
The top.
8,000 liters of water.
Yeah.
Okay, and remember that one felt awful at the time? Okay, we'll do it like in about 10 seconds here, okay? Are we okay with this? Can I go to this timer should move on? Can I move on to the next page? Right. See, this is the problem having one sheet, now I gotta wait. This is why I don't like one sheet of paper, but that's me. Okay, I'm gonna throw one more on with like square roots and stuff like that, okay, and see how it goes. Okay, and then we'll move on to the fish tank question. And then that's, well, that might be a good one. Okay. Okay, now we're done? We're good? Okay, example 5 says, this only has 1 star, which means it's awesome but not awesome. If f of x,
Oh, h.
f of x
Okay.
equals 3 over the square root of x plus x cubed, find the equation of the tangent at x equals 2. Undefined, incorrect. Oh, you did this already?
For the,
Derivative? Yeah. Go to this as a class, you guys want to try yourself?
Can you like
Try yourself. I will give you 3 minutes. I will give, yes. I will give you the first step, and then you guys take it from there. F of x is equal to this. What is another way I can write f of x?
3 times 1 over 6.
Okay, hold on a sec. We'll not do derivative here. What just in general? When I see divided by a square root, what should I change that into? Sorry? Yeah, negative, I'm going to call it negative 1/2. So I'm going to call it x plus x cubed to the negative 1/2. That should be the absolute first step. Now, this is a chain. Why is this a chain looking at it?
Because there's an exponent outside of the bracket.
Yeah, there's something in the brackets, and there's an exponent. Okay. Someone was asking, when would you? How can you tell me it's a chain rule when there's not? When there's something complicated, is basically it. When we get to sinusoidal functions, you'll have to take the derivative of something like this. You'll have to do. Okay, that'll be a chain rule too. Okay, right? Because there's a function inside a sine, right? But I don't want to scare you yet. Okay, but that's the sort of stuff you'll have to do because it's a function inside of a function. Right? Anytime there's something weird going on, and in this course, it's going to be probably every derivative we take from here on out. It's going to be chain rule from here on out. So this is an important lesson. That said, I'm going to hit pause and give you guys a chance to take that derivative, and then we will come back after the break.